Assalamualaikum warahmatullahi wabarakatuh and good day everyone. Today I will be presenting the mathematical modeling of South Korea's population growth. We are using a separable first order differential equation to understand how the population changes over time based on a constant rate of growth.
Okay, so I will be presenting the population trend from the year 2006 to 2026 based on the data shown in this table. So starting in 2006, the population was approximately 48 million. From 2006 to around 2016, we can observe a steady increase in population each year. For example, the population rose from about 48 million in 2006 to 51.3 million in 2016. This shows consistent growth over a decade. The population continued to increase, reaching its peak in 2020 at approximately 51.86 million. This indicates that the country experienced continuous population growth for about 14 years. However, after 2020, the trend begins to change. From 2021 onwards, the population shows a gradual decline. For instance, it decreased from 51.85 million in 2021 to about 51.6 million in 2026. This shift suggests that factors such as lower birth rates, higher mortality rates, or migration patterns may have influenced the population decrease in recent years. In conclusion, the data shows a steady growth from 2006 to 2020, followed by a slight but consistent decline from 2021 to 2026.
To begin, let's define our variable. We let P of T represent the number of people in South Korea at any given time T. Our starting point is differential equation dP over dt equals K times P. This states that the rate of change in the population is proportional to the current populations, where K is our constant of proportionality. By integrating both sides, we move from the differential form to the general solutions. After applying the natural log and exponentiations, we arrive at our growth model. P equals A times E to the power of KT. Move to the next part where setting the initial condition. Now we apply real world data to find our specific values. We set our base year T equals to 0 as year 2006, where the population was 48,006,518. By plugging these into our formula, we find that our constant A is equal to the initial populations. Next, we need to find the growth constant K using data from the 2007 or T equals to 1, where the population rose to 48,178,118. We solve for K using natural logarithms. This gives us a growth constant of 0.0036. Testing the model. With our particular solution finalized, we can test the model's accuracy by looking at future and past values. For the future value in 2016, if we look 10 years ahead to 2016, where T equals to 10, the model predicts a population of 49,751,309. It is interesting to note that the actual recorded populations in 2016 was 51,297,839. This tells us that the growth rate was actually slightly higher than our 2006 to 2007 constant suggested. For the past value in 2004, we can also look back 2 years before our start date where T equals to -2. The model calculates a population of 47,664,972, which is quite close to actual value of 47,697,075.
At the beginning, both lines increase gradually, showing that the population is growing at a steady and controlled rate. This suggests that factors like birth rate and migration are relatively stable. As time goes on, the red line starts to level off slightly, indicating that the actual population growth is slowing down. However, the blue predicted line continues to rise at a constant rate, showing a faster increase than the real data. This difference means the model slightly overstimulates the population in the later period, while the actual data reflects a more realistic and moderate growth. In conclusion, the population is increasing over time, but the real data shows slower growth compared to the predicted model.
So I will talk about the discussion and analysis for our assignment. For question number 1, is the value calculated from the particular solution consistent with the actual values? So the answer is no, because based on our sample of calculation, example at the 2009, the predicted value that we get is the 48,527,798. It is different with the actual value, and the difference of the both value is the 18,889. So it may have a different in the value. So for question number 2, the question asks them to calculate the percentage error. So we take the sample of the population at 2009 and 2013. At the 2009, after the calculation, we get the percentage of 0.039%, and at the 2013, the percentage error that we get is a 3.437%. Next, for question 3, if there are differences between the actual values and the calculated values from the particular solution, explain the possible reasons. So they have a differences in value because in reality, the growth rate, which is a K, is rarely constant compared to the constant rate of growth in our particular solution. It's a fact based on the birth and death rate that change that occur uncontrollably. And then the actual population values are heavily influenced by the immigration and emigration. Question 4. What factors that influence population growth in the past in South Korea? So there are few factors. One of them is the population momentum, which is the influenced by the eco generation. This generation is the last baby boom generation that born after the Korean War. Even with fewer children per woman, this large cohort of young adults create a high total number of births in the 1990s and early 2000s. Next is the increased life expectancy. During this period, South Korea experienced rapid improvement in health standards, leading to higher life expectancy and a large aging population, which increased the total population count. Lastly is urbanization and concentration. The proportion of urban residents has increased continuously, passing the 50% level in the late 1970s and reaching 80% in 2000. Okay, for the last question, what factors do you think may affect population decay in the future? The factor is, firstly, is a rapidly aging population. In South Korea, the proportion of people aged 65 or older is rising faster than anywhere else in the world. Secondly is the pressure in cost of living. There are a skyrocketing housing price in South Korea, particularly in metropolitan areas like Seoul. And then the high cost of living that acts as significant deterrent to starting families especially for the young generation in South Korea. Finally is the shifting social norms regarding marriage. Marriage is no longer seen as a mandatory life stage, and they often living solo living as their mainstream lifestyle.
In conclusion, the population trend in South Korea from 2006 to 2026 shows a significant shift from steady growth to gradual decline. Using the Malthusian model and first-order differential equations, we were able to analyze and model how the population changed over time. The increase in population before 2020 was mainly influenced by factors such as population momentum, improved life expectancy, urbanization, and economic development. However, after reaching its peak, the population began to decline due to an aging society, rising cost of living, and changing social norms regarding marriage and family life. Overall, this study highlights that while mathematical models are useful in predicting population trends, real-world factors such as economic conditions and societal changes play a crucial role in shaping future population patterns. Thank you.